Winston, I'm going to walk through this PR 1510 on asynchronous image loading. If you're not familiar with it, I would strongly recommend you watch this video. It's about 11 minutes long and completely explains what it does and how it works and how it works from a user's point of view, and detailed performance monitoring, graphs, and in general, it explains a lot. So this is the PR. I'm going to talk about these sections. So the top is the image layer itself. The changes there were relatively small. It's mainly hooking it up so that it calls into the chunk loader. The chunk loader and its related classes are all brand new. It's not a lot of code, but it's not a tiny amount. I didn't check. VisPy, very, very small changes. The tests it took a while to make these changes, but they're like probably 10% of the way there for testing, but at least it is giving us some ideas of the kind of things we can do to have multiple passes and stuff like that. And the command layer I may or may not talk about because it's pretty basic. So let's see. Image layer is mostly diff, so I'm going to go to this program. And where is the image layer? So the base image first. Let's see what changed there. Not much. So we have a new loaded event for when stuff is loaded in memory, which the chunk loader, that's like the big change, right? So now when you go navigate to a slice, the data is, if it's asynchronous, it's not yet loaded. And so the layer has this loaded property, and currently it's not displayed in VisPy until it's loaded. That will change, but that's what it does right now. So that's the base class. Image itself, let's look at it next. So it's importing this chunk stuff, which is great. It changed the comment. Blah, blah, blah. It passes this RGB to the image slice. So image slice is something I introduced with a previous PR. So image slice is kind of like the slice of the image that you're viewing. And all I did was add this RGB flag for some reason. It has the loaded property. The loaded property is if the slice is loaded. Got rid of that variable. So the big change, this is the big change, right? So, but previously you would just immediately call asArray, and you'd call asArray on the thumbnail, and you'd call asArray on multiscale. So the first part is multiscale, the second part is single scale, sorry. So anyway, you call asArray in every case, and now you never call asArray. You get the image, you record the indices, you get the thumbnail source. That's multiscale. For single scale, you get the indices, there is no thumbnail, blah, blah, blah. And then you call self-load images. So self-load images and the other thing, chunk loaded, are new. So I'm going to go to VS Code so it'll be easier to read. Where did the VS Code go? So we're in image, so I'll just load image. And let's go down to load images. So we have just called load images because we want to load some images. So this little chunks dictionary, you can give different types of images you want to load, different arrays. I have two here, the image array and the thumbnail source. Thumbnail source is only present in multiscale. Now we call into the chunk loader to create a request. We'll look at that later. And then we call into our slice and we say load the request. And if it does load it immediately, if it does not load it immediately, we basically signal this event because we're now unloaded. We now do not have our data because it's being loaded. If it was loaded right away, which can happen, then we call chunk loaded immediately. If we called the signal loaded, then sometime later, someone will call chunk loaded for us. And that, in a nutshell, is asynchronous image loading. That's really all there is to it. So let's look at the case. So whether we immediately loaded it or we were signaled later that it was loaded, we first say, is this request that's been loaded up here, is it compatible with us? It should be always, but if it's not, we just drop it. We could assert here or something, but for now, we just drop it because there's no chance in the world we want to use a request that's not for us. We do this transpose chunk thing, which transposes everything. Probably that could be done in the worker, but I didn't want to change that without looking into it. We get the main image. We say, is this really RGB? So this is kind of like a new pitfall. If you're loading asynchronously, you may not find out that they've used the wrong RGB status or they lied about it, basically. But we just assert. Pass the data to the slice, which we'll look at. Notify the world. This was always in there. Notify the world about loaded. That's new. If not synchronous, refresh. That is because we need to redraw everything now that we have the data. So that's it. That's it for image. That's all we changed. And so let's look at image slice. This has a bunch of new functions again. So let's see. Set raw images is new. Load chunk is new. Chunk loaded is new. So let's look at them in VS Code so our eyes don't bleed. Image slice. Image slice. Set raw images is just this little wrapper that sets both the image and the thumbnail and sets the loaded status. Once we set the raw images, we're loaded, and our event will tell everyone that we're loaded. Load the chunk. Note the key that we'll look at the key later, but the key is basically the indices and some other stuff. So, hey, we're looking at this key, but it's not been loaded yet. Now let's try to load it. Now this may return synchronously if the image is ND array in other cases, or it hits the cache. But if not, if it returns none, that means the load is in progress. Chunk loaded, again, this gets called whether we load it synchronously or asynchronously. Again, if the key is not for us, maybe this is not needed, but this is to be sure. Throw it away. And now set the raw images. So we're done. So that's image slice. So basically we added asynchronous loading to image slice. Image utils is nothing changed really. Image view is this tiny little class. All we did was get rid of this optional converter that we weren't using. Not interesting at all. So let's go back to the doc. So we did these. Let's cross them off. There. Okay, chunk loader. This is all brand new code, and it's not that complicated. So let's look at it. So we can do this all in VS Code because it's all new. So here it is. It's going to move to components, but right now it's in utils chunk. So let's look at the init. This is what we expose to the world, our config. Layer info, which is per layer information the chunk loader is tracking. Load type, synchronous, asynchronous. The chunk loader itself, synchronous loading context object. The chunk key and the chunk request. So let's look at utils first. Get it out of the way. Get data ID. This might have to change, but this is kind of getting an ID for the data if it's multi-scale or single scale. Hold the GIL. We're not using this is to hold the GIL. Stat window is a little class that probably there might be a better way to do it, but it's just keeping just average right now. I was going to do standard deviation. We'll see where we're using that. Let's go. What's the right order to look at this? Let's just go to the loader. So this is the loader. It is 480 lines, not a lot of code. So blah, 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 import all this stuff from the... So look, this is the meat and potatoes of everything. This is the chunk loader worker. This is the only function that runs in another thread or another process. And it's the same whether it's a thread or a process. and it has one line, which is load chunks, which basically just calls as array on every array in the request. So the worker does the absolute minimum we can do, and that's what we want, because we want, well, I don't know if we want that, but that's what it does now. It does the minimum. Create executor, this executor, I guess. This lets us do processes or threads. Here's the chunk loader. So it has a synchronous mode. That means we're going to load every load synchronously by default. Why would you want to do that? Well, 1 is for testing, and 2 is just if your data is freaking out asynchronously, you can switch to synchronous mode. Load seconds I haven't used much, but that adds a synthetic load, a synthetic sleep, a synthetic delay to every load. Should we use processes or not? How many workers should we have? Make the executor, make the delay queue, which we'll show you later. We need a feature map to keep track of our features. We need a chunk cache so we don't reload stuff, although caching is very in progress right now. We need a new chunk loaded event we'll talk about. Blah, blah, blah. So create a request. We saw this earlier. The image creates a request. It's just kind of funky how this works, but basically we just create a new request and store information in our layer map because we need to keep track of it. As array, that's broken out for timing reasons. Load chunk is, what the image calls into when it wants to load. So if we should load synchronously, then do it. That function is actually pretty funny. So load synchronously calls, do async load. Do async load is this funny long, Boolean. So it's basically all the cases. So if we're forced on synchronous, then it's synchronous. If we're forced on async, then it's async. Otherwise, it must be auto. If it's auto, but we're always doing synchronous, then do synchronous. But if we have a delay, we can't do, I might remove that, but right now it does that. If info loads fast, that means if we've been getting fast loads previously, then load synchronously because we can, it's fast. Otherwise, load synchronously if it's in memory. So this obviously could change. That's just how it is now. So if we load synchronously, then we do load chunks. That does as array. And that's it. So if we load synchronously, we're done. We return the request. Otherwise, is it in the cache? If not, clear pending request. That is what deletes, removes requests for chunks that we no longer need. Anything that was pending, we'd get rid of it. Put the load seconds in there. Now add it to a delay queue. Now we're done. So that was a load. Synchronous up top, asynchronous at the bottom. So what happens next? Clear pending. We don't need to go through that, but it clears pending features. Get request is... Oh, this is the feature itself. So the feature has a result. This will block if the feature's still running, but in our case, we always know it's not running. So I'll look at where we do get request. So get request is the first thing in our done handler. Done handler may be called from a worker. When I say may, I mean the documentation doesn't specify whether it's going to be called from a worker or not. But in my experience, it always has been called from a worker. Maybe it's because Mac OS, maybe it's because Python 3.8. I don't know why, but it always has been called from a worker thread. So if there is no request, the feature was canceled. There's nothing we can do. Otherwise, add these perf events. We don't need to worry about that. Add it to the cache. Get the info. Note that the load has been finished. This records some statistics. And then fire this event that it was loaded. We'll talk about who listens to that event later. Wait, I don't think we actually use, but we could wait on stuff. And this on layer deleted is very funky and probably should be changed, but this prevents a crash. That's it. And then there's this synchronous loading context object, which is used in the tests right now, but could be used in other ways. So that was the chunk loader. Not too bad. So let's look briefly at the cache. The cache is the least confident part here. This is subject to change because no one has even filled up their cache, so no one knows what happens. But this uses a package called LRU cache from Cache Tools. So we won't even talk about it since the cache needs work. Config, this is a little class that loads a config file. I'm thinking this is the async config file rather than the chunk loader config file because there could be other asynchronous configuration parameters like related to graphics or rendering. But if that doesn't happen, we could rename it. So this just has a bunch of settings. Tally's pointed out this is written in kind of a silly way, so we're going to collapse it down. But basically, these are the settings. So synchronous, yes or no, number of workers, it can be any number. I want to add something here so you can request n, which means n, cores, or 2n, or 1/2 n. Log path, use processes, otherwise we use threads. Delay is for the delay queue I'll talk about. Load seconds is that synthetic load you probably don't need. Let's look at the delay queue. It is 180 lines. It's pretty simple. So basically you stuff in requests into this queue and they get delayed for however long. By default, it's 100 milliseconds. The reason we do this is because once you start a feature, you can't cancel it, but you can trivially remove things from the delay. So if you clear for a data ID, we can just clear those guys. And so basically this prevents us from repeatedly asking for loads over and over and over again if you're scrolling through the slices really fast. This solves that problem. So we only load if you pause. And we can put in a special mode, so if you click next, it will load that faster, but I haven't bothered to do that. So the submit is used internally. Run, this is the actual thread. It's kind of nice now because I fixed it. So it basically submits the due entries, sees how many are left. If there's none left, it waits on an event. Otherwise, it sleeps for the exact amount. This will tend to go over a little bit, but we don't really care because we always submit all due entries, so we never miss an entry. And this is submitting due entries. You just run through. And we've got locks and stuff because that made it super reliable. But there might be a way to do it with less locks. Info, this is kept per the chunk loader keeps this for information about each layer. It's just statistics right now. Oh no, the load info is just statistics. The layer info has statistics and recent loads and load type and a weak ref and everything we want to know about it per layer. Now you could stuff some of this stuff into the layers, but I think that would be a bad idea. I think the chunk loader should keep track of its own stuff and we shouldn't pollute the system. So I think this is good. Megabits per second, loads fast. We can change by policy, but it's just saying, has it been loading fast? Recent load string, is it all sync? Is it async? Is it mixed? Load finished. This is what you record when the load is finished. Update some stats. It's all stats. So that's that. Request, time span class. We probably should have a common one. I think I have multiple time spans. The chunk key, this is probably a little messy, but it's got everything in the kitchen sink right now. It's got the layer ID, the data level, which I had to add in for multi-sync, the indices, and that whole thing is the key that goes in our cache and then we use. Maybe that could be slimmed down, but this really makes sure that it's the one we expect. Chunk request, this is the request. So the main thing here is this that's the timers dictionary. The main thing here is this chunks dictionary from string to array like. This is what you're loading. Load the image, load the thumbnail. I anticipate when we have a octree, we might load, a grid or nearest neighbors or above and below or whatever. So we can give them little names. If we don't use the little names, we could change this, but this keeps it flexible. So In memory, are they all ND arrays? That's how we check. Time block. This is a long story about processes that we had to do something special. I'm hoping we can just get rid of processes and then we can use a regular perf timer. Load chunks. Again, some of this is with timing. But basically this is called in the worker. So we get a process ID and we get a thread ID. Add perf events. Again, that's really for processes, but we use it for transpose chunks. This is what we call after it's loaded. This maybe could be done. I assume this doesn't take any time. Image. Basically image and thumbnail source are like special names that we expect to be there. Is compatible and index to tuple. I'm guessing you don't even need this, but I did that to convert to a tuple. Okay, we got that. We did it all. That's the chunk loader. So let us mark that. Okay, VizPy. These are probably diffs. Let's look at it. Image, VizPy, vendored. Oops, that's the wrong one. Let's start with this vendored image. There's just one change. If it's not visible, then do not set the data. So this, I think, is going to change with the octree. The octree is going to be a container. The container is going to be always drawn. The, it'll be a different story. But for right now, if you give us data and we're not visible, we don't set it because it calls as array right there. VizPy base layer. All this is loaded event. The loaded event updates the visibility. That's it. If it's not loaded, it's not visible. If it is loaded, it is visible. This is the image layer. As type was broken out for timing. If it's not visible, then the data change we ignore. And then we just break that up for timing. So very, very minimal changes. This will change soon so the worst thing about this PR right now is it turns black, especially on multi-scale. Super annoying. So we're going to, as kind of a version 0 of the octree code, create some kind of container. The container can manage its children. The children can be visible or not visible, but the container itself is always drawn. So I think that will be much better. And it'll be like a whole new object. So these are minimal changes. We're going to have some new like VizPy _ image chunk or octree image or something. That's it. Let's go back. We did that. So that's really the important part. We could stop there if you're pressed for time, but here I'll just briefly, I won't even show the code here, but the tests need a lot more work, but I have a new flag called async only, and I have a new mark called sync only. And if you're running async only, it will not run the sync tests. So it's kind of a workaround. And also if you run async only, it sets the loading to be asynchronous. If you don't set it, it sets the loading to be synchronous. So it does what you expect. Configure loading and skip sync only accomplish that. So we need a huge change here, which is I think every task needs to be run asynchronously. And the issue is even the ones that use ND arrays, which currently load synchronously because they're fully in memory, should run asynchronously. So I think what we need to do is force the chunk loader into asynchronous mode. And then we probably need a call in the middle of every test that says load. And if we're running in synchronous mode, it does nothing because you don't need to load. And if we're running async, somehow it needs to wait for the load to happen. That way, we're running every single test. They're all running asynchronously. They're all running with worker threads, and they're all checking the results. Now, that doesn't mean we won't also have special async tests, but that'll at least get the entire test suite running with async. And then the commands, I won't even go through those. Humanizes third party. Loader, so there's a bunch of commands. Viewer.loader, viewer.loader.layers, viewer.loader.loads, viewer.loader.config, viewer.loader. I don't know. There's a bunch of commands. And tables, there's a bunch of formatting stuff that I just kind of made up. There are probably really good packages for that, but I didn't want to get into that. And utils, I would demo it real quick, but I haven't run Napari. Well, let's see. This is going off script here. I have VS Code. And it has a terminal. And in that terminal, we have Napari. And there it is. So here's an example. Here is the console. I'm not sure how to make the font bigger. Viewer.loader. These are the commands. So we had this whole other PR. Hey, let's just put these commands into viewer.command and make them general. And then we said, oh, that's a much bigger. That's a bigger thing. So they're just loader right now. So cache doesn't work. Why not? Oh, loader. Viewer.loader.cache. Viewer.loader.config. That's my config. Viewer.loader.layers. Those are my layers. You've got the mode is auto. The mode can be sync or async or auto. Loads, this is if your loads are mixed, async or sync. Layer name, layer type. Dask is your data instead of ND array. Levels, loads, chunks, these are statistics. Blah, blah, blah. We can actually do this. Get some loads in there. There, now we have some numbers. These are synthetically set to this time, so. But loads, so we type loads in the layer index, and those are the specific loads, just shows the last 10 and their exact times and stuff. And I would demo the switcheroo thing. Let's see. So this slice has half fast and half slow. So if I do this, if I single step through, it's synchronous to start, and then it turns asynchronous because it's slower. So if we look at the viewer.layers.loads, not layer, viewer.loader.loads. So this is pretty cool. The first, actually it started as async because it's a Dask array, and it saw that was fast, and then it switched to synchronous. And each load is taking about 10 milliseconds. I say load, but you're really just calling as array on an in-memory data. Really shouldn't be 10 milliseconds. I don't know why it's that slow, but that's what it's taking. So it says synchronous, and then boom, this one takes a second, and it immediately flips to async. Right now we use the stat window of 10. It probably should be faster. That's pretty much all I can even think of to say. So I would say we did all that. Okay, we're done. Signing off. Hope this was informative. I'm going to put the link to the other first video in the same place I put this link at the end of 1510. See you later.